Oh, hi guys, I'm live. Sorry I'm going live so much. With my coffee. But I have time on my hands and I have things on my mind, so I'm going live a lot. I apologize. I mean, there's only so much time I can sleep. I don't deprive myself of sleep, but I also have lots of energy, and I'm not sleep deprived to the point where I just need to catch up by getting hours and hours and hours and hours and days and days and days of sleep. So sometimes I am alone in the house. I'm okay with my sleep, and I got stuff on my mind, so I'm going live. So I apologize. And this one I hope isn't a stupid one. This video here. I'm doing some bed rant. It's a topic that you might think is dumb. This whole video may tank really badly, but I'm going to try it anyway. What the heck, right? I'm going to talk about numbers and letters in math and in music. Let that sink in. Numbers and letters in math and numbers and letters in music. And if there's any correlation, let's just see if there is any. Oh man. Well, in math, you have something called base. B-A-S-E. Base is the number of characters in your number system. So if you have base 2, in math you always have a 0. In music you always have a 1. There's no 0 in music, but you don't start with, in music you start with 1 all the time. There's really not a 0. But in math you start with 0. There's usually a 0. There's almost always a 0. So that's one difference already. We've made progress. You start with 0 in math, you start with 1 in music. Usually, that's just how it goes. But you have something called base, like I said. So if you have base 2, see, since you always have a 0, if you have base 2, you'd have a 0 and 1. That's it. 2 characters, because it's base 2. Not 1, 2, but 0, 1. If you had a 2-note scale in music, it'd be 1, 2, not 0, 1. It'd be 1, 2. But there's really not too much going on with 2-note scales in music. But binary is base 2, 0, and 1, and that's why digital is base 2, because digital is just on or off switches, yes or no, 0, 1. 0 is not, 1 is yes, 0 is no, 1 is yes. And since there's only 2 options, there's only 0 and 1, it's base 2, so digital is binary. In computers, and if they ever make it to trinary, that'll be a leap for the better for the AI people. Because what if you had, instead of 0, 1, what if you had -1, 0, 1, where -1 is no, 1 is yes. It's an opposite FU, isn't it? Computers can't ignore things yet. If they can ignore things, that would be a step toward being human. Because humans can say, I don't care. Computers can't do that. If you had -1 is no, +1 is yes, and 0 is I don't care, that'd be trinary. You could call it 0, 1, and 2. You could make any one if you want. You could make 0. You could make 0, I don't care, 1, yes, 2, no, or it could be 0, yeah, no, 1, I don't care, 2, yeah. It doesn't matter how you figure that. But that'll be dangerous for humans when computers can do trinary, because they'll be very human-like at that point. What if your AI dude could ignore you if he wanted to? Now he's getting human, isn't he? That would take trinary, though, because that'd take a third alternative. It's like fight or flight or freeze. Fight is like 1, yes. Flight is like -1, no. Freeze is like 0. Computers can't freeze. They can only fight or flight. If computers could flight, or freeze, humanness is right there. But I'm going off on a tangent now, because that's not what I meant to talk about. But hey, the conversation went that way. Now, what about else? There's another thing in math. We use base 10 generally. That means you have 10 characters, but you always have a 0, which means you have a 0 and 9 other characters. Those other 9 are 1, 2, 3, 4, 5, 6, 7, 8, 9. But you have 0, so it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, which is 10. So you have base 10. 0 through 9, 0 through 9, 0 through 9, on and on and on, base 10. Why? Who cares? Well, music has a base 7, but doesn't start with 0, it starts with 1. So you have 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7. The only catch is that the one that ends is also called 8. So you can go 1, 2, 3, 4, 5, 6, 7, 8. but 8 is equal to 1. 8 is the octave. That's why octave means 8. Octopus means 8 legs, or 8-sided thing, 8-legged thing. Octave, 8 notes. So 1, 2, 3, 4, 5, 6, 7, 8 is really 1, 2, 3, 4, 5, 6, 7, 1. What's that like? That's like base 7 in math. Only if you did base 7 in math, you'd have to start with 0 anyway, not 1. So base 7 in math would be 0, 1, 2, 3, 4, 5, 6, and then 0 again. But that's base 7 in math. Why do I say that? Why? Who cares? And what am I talking about? Well, there's a thing called the new math, NEWMATH, where they tried base 7 for a while. Instead of 0, 1, 2, 3, 4, 5, 6, 7, 8, not 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, they tried 0, 1, 2, 3, 4, 5, 6. Literally base 7 math, called the new math. Google it if you want. If you don't Google it. But there is such a thing. I had a new math book at Harvard College. The professor just gave it to me. Interestingly, new math is 0 to 6, and 6 is the last digit, highest, and then the regular math is 0 through 9, and 9 is the last digit, and 6 and 9 are inverted numbers. And not only that, 6 is 1 less than 7, which makes it a biblically imperfect number spiritually, because 7 is spiritual perfection in the Bible, and 6 is not that, so 6 is bad. But then 9 is 1 short of 10, and 10 is earthly perfection, so 9 is bad in an earthly way. And not only that, 6 and 9 are reversed of each other. So there's a lot of symmetry going on there. But if you had base 7, the new math is just like a diatonic major scale, the harmony, the music that we write. 1, 2, 3, 4, 5, 6, 7, 8, 0, 1, 2, 3, 4, 5, 6, 0. New math didn't work, though. It didn't work. It didn't accomplish anything. Confused people, didn't work. Messy, messy, messy. In fact, there's a line in the movie. See, I was testing my memory here. There's a line in the movie called When Harry Met Sally with Meg Ryan and Billy Crystal, where he goes, yeah, it's the new math. It's driving kids crazy, blaming the new math on kids being crazy in that movie here, When Harry Met Sally. I've got a near photographic memory, and I remember that just from watching it. Like, I watched the movie like twice in my life, or once. But he said that. It's a movie where he goes, Meg Ryan imitates, I'll have what she's having. That movie. It's also when Billy Crystal says it's a new math, it's driving them crazy. But there's that. So is that boring so far, or is it making some correlations? Like, music thinking is like new math thinking, only the numbers start with 1 instead of 0, and it's each number stands for a note. Now let's go further, or let's go sideways. Notes in music aren't just numbers, though, they're also letters. So 1 can be any note in the chromatic scale. And so if I say C major scale, and I call that 1, 2, 3, 4, 5, 6, 7, 8, then 1 is C, because it would then be C, D, E, F, G, A, B, C. C is 1. That's in tonal music so far. So far, we're talking about tonal music. At least that's what I'm talking about. If you make B flat 1, then 1 is B flat. And then you would have B flat would be 1, C would be 2, D would be 3, E flat would be 4. E flat would be 4. 1, 2, 3. B flat, C, D, E flat. F would be 5. G would be 6, A would be 7, and B flat again would be 8. I think I did that right, actually. So there 1 was B flat, but 1 can be any of the notes in the whole chromatic scale. So you have 12 notes that can be 1. You have different spellings of those notes. In general, you can spell different notes different ways. And you can use different scales. We call 1, 2, 3, 4, 5, 6, 7, 8 a major scale, though. Typical, that's common, that's practice for Western music. So if you want to say a minor scale, natural, you'd say 1, 2, flat 3, 4, 5, flat 6, flat 7, 8. Or 1, 2, flat 3, 4, 5, flat 6, 5, flat 7, 1. New math, but starting with the 1 and adding sharps or flats within a scale and having any of the 12 notes to be the 1 note. Music's not simple, guys. Music has a lot of math to it, and it's a lot of complex, not junk or stuff or content. that is a lot to process. A lot of people just don't do it, but then you're just stuck. You hit a wall that way. Try to do it, but just realize it's going to be hard, and don't expect no problems, and don't expect overnight results. But whatever, unless you're a genius, in which case, don't expect problems, expect overnight results. Yeah, there's that. And but let's go back to math. You thought I was going to stop. You didn't think I was going to make a correlation to math, did you, for a second? Math has letters too. Take algebra. Constants are the beginning letters in the alphabet in math. So if you have A, X plus BY equals C, Z or something, the A is a constant. Like A would be just 3. And then if I say AX plus BY, B could be 4, equals 5, CZ, C could be 5. So A, B, and C are constant. I just made that equation up. A and B and C are constants, but the variables are the end of the alphabet. So the end of the alphabet, X is at the end, and that's a variable. So I could say AX could be 3X plus BY. Y is at the end. Y is another variable. Toward the end of the alphabet could be 4. Y if B is 4, and then equals CZ. Z could be 5, and Z would be a variable at the end of the alphabet. So you're not as quick to define the X, Y's, and Z's, but the A, B's, and C's are all straight constants. Usually, I'm just talking general. It's a fast rule. You don't usually see violations of that too much. Nobody's trying to be a hero just by screwing up the standard nomenclature. That doesn't make you sound smart. It makes you sound stupid or not. I don't know. It doesn't help anything. Like the quadratic formula. If you have an equation, AX, how's it go here? If you have an equation, AX squared plus BY plus oh gosh, I'm not even sure I know the quadratic formula anymore. I trouble here. The quadratic formula is X equals negative B plus minus the square root of B squared minus 4AC over 2A. That's the solution to a quadratic equation. And I think the formula is AX plus BY equals CZ. Wait. Quadratic formula. Okay, I think it goes like this. Y equals AX plus B. Y equals AX plus BX squared. Maybe it's like this. Y equals A plus BX plus CX squared. No, it's like this. Y equals AX squared plus BX plus C. I think that's how it goes. If Y equals AX squared plus BY plus C, then the solution of that equation is I'm reaching here because it's been so long since I've done this, is X equals negative B plus or minus the square root of B squared minus 4AC over 2A. Something like that. I don't know. But the point is that the variables are X and Y. The constants are the A, B's, and C's. Okay, I probably screwed that quadratic formula up, but you can Google that, and I learned it in high school, and it's been so long, I barely remember what they're talking about now. Anyway, I know you get the point, I think. So that there's one more thing in math, though, in higher math, which I'm actually better at than basic math, but that doesn't make me smart. It just means I haven't done basic math in a long time. Letters in math can be special numbers in math can be given letters, such as E is the base of the natural logarithm, such that Y equals e to the x is the exponential function. And it turns out that the derivative of e to the x is e to the x. That number e is 2.718281828, but it doesn't compete. It goes on and on. It doesn't keep going 18281828. That's a coincidence. It's a transcendental x. It's an irrational transcendental constant, but given a special letter e. Okay, let's do one more. Let's do two more. There's number pi. Pi is actually a Greek letter. It stands for the ratio of a circle's circumference to the circle's diameter. This number is 3.14159.265, and it goes on and on and on, and that's called pi. It's a Greek letter, but it's a special number, the ratio of a circle's circumference to its diameter. Third one is I, not the I, but the letter I, little I, is square root of -1. Stands for imaginary, I think. Square root of -1. Number such when multiplied by itself is a negative number. No such thing. So they just call the I squared equals -1, and I is imaginary, so I equals the square root of -1. It doesn't exist, it's imaginary, but we call it I. So there's some numbers that become letters in math, and there's numbers that become notes, which are letters in music. I think that's interesting. We're almost done. Almost hang up the phone here. Let's do one more thing though with the music. We have pentatonic scales, but they're generally not numbered 1, 2, 3, 4, 5. Oh, I got to do two more things with the music. I'm glad I thought of that. I'm glad I said that because it reminded me I got two more things, not just one. You don't have bass 5. You don't have a pentatonic 1, 2, 3, 4, 5, and you just 5 is considered a 7-note scale with 2 notes missing rather than a full-fledged 5-note scale. You don't have a hexav, which would be a 6. 1, 2, 3, 4, 5, 6 would be the octave of a pentatonic, and you'd have to have a hexav. Bunch of mess. We don't do that. I've thought of it. It doesn't work. Two other examples of numbers in music, though. Which do you want to do first? Let's do the note one again, but this time let's do atonal. Let's do atonal music. Atonal music doesn't use keys, so you don't. Here's an example. I said music always starts with 1, and then I'm going to make myself a liar because I didn't realize I was, but I am. There is a form of music nomenclature that does start with 0, and it's called the pitch class clock. It's for atonal music. It's for when all notes are equal. You play one note, and sometimes you can't play any other note. You can't play that note again until you played every other note. So every note gets played once, only each time. So only, and then you start over and do it. Start with the first note again. So no note gets played more often than any other note. All you end up doing is arranging the 12 notes in order that you choose. And then you have 4 versions of it. You have the original, which can be played on any of the 12 notes. So that's 12 possibilities. Then you have the retrograde, which is the original backwards. And then you have the inversion, which is original melodic inversion and melodically inverted. Then you have the retrograde inversion, which is the retrograde of the melodic inversion. Oh my God. And there's 12 versions of each of those because they can all 4 be played on the 12 chromatic notes in the chromatic scale. So there's 48 forms for any role you choose, and you can choose whatever role you want. But it doesn't, though. It starts with 0. And if you take pitch as if the 0 pitch, instead of the pitch starting with 1, they start with 0, like a clock. 12 o'clock, but 12 is actually 0 also. If you had 0 o'clock, it would be 12. And if you had 0 o'clock, 12 would be 0 o'clock. And if so top north is 0. Then you have 1, 2, 3 is east, 4, 5, 6 is south, 7, 8, 9 is west, 10, 11, 9 is west, 10, 11, 12 is 0 again. Or you could say 12, but it's still 0 again, is north. So you have 0 through 11, which is actually base 12 or mod 12, M-O-D, modulus 12. Yeah, it's like base 12, only everything repeats in 12 instead of 10 or instead of 7. So there's that. And it starts with 0 instead of 1 this time. And then if you say pitch, you mean a note without a rhythmic value. Pitch is like velocity. Velocity has speed with direction. Pitch has a note has a pitch with a time duration. So to say a note, you have to say an A quarter note. To say pitch, you can just say A, but A is just a pitch. To say an A note, you have to say A eighth note, or A is a half note, or a B quarter note. That the note plus the time duration is a note. Just the note without the time duration is called a pitch. So if we take time out of it, you have pitches, so you can have 0 through 0, where 0 is any of the pitches you want to start with. But then you got to make even one more generalization than that. What about octave differences? If every time I go back to 0, which is actually 12 again, I have an octave higher, or if you go counterclockwise, an octave lower, then all those, then 0 would be different than 12, which would be different than 24, which would be different than 36, etc. But we call it pitch class when we say that all notes that are an octave apart are the same. So we call all A's the same, even if they're octaves apart. So A440 is still the same as A220 or A110. They're all just, if A is 3, then all 3 of those are 3. But actually A would usually, if C is 1, A would actually be 9. So if A is 9, then if A440 is 9, then A220 is 9, and A110 is 9, and that's called pitch class, meaning the class of all notes that are an octave apart all get the same letter or number. So a pitch class clock is all 12 notes stripped of time and with octave equivalence. So 0, if 0 is C, 0 is any C you want, anytime you want. 1 would be C sharp, 2 would be D, 3 would be E flat, 4 would be F, 5 would be, 0 would be C, 1 would be C sharp, 2 would be D, 3 would be E flat, 4 would be E, 5 would be F, 6 would be F sharp, 7 would be G, 8 would be A flat, 9 would be A, 10 would be B flat, 11 would be B, and then 12 is 0, which is C again. And you don't care what, like I said, it's pitch class. No time value, and all octaves doesn't matter what octave you're in. It's called the pitch class clock. It's base 12 or mod 12, and it starts with 0 rather than 1. And the question I asked Alan Holdsworth when I talked to him for 20 minutes was, what I've been thinking of the pitch class clock, what note should I make 0? Should I make it C? And he said, no, make it D. D as in dog. And he was right. Good point. D is symmetrical. If you have D is 0, then F is 3, B is 9, and A flat or G sharp is 6. Really good symmetry there. C is oblong, E is oblong, is C being 0, E being. But since D is the middle of the circle of fifths, why not make that 0? And make that 0 in the pitch class clock. And that was Alan Holdsworth's actual answer to me in 1998 when I saw him at the Catalina Bar and Grill in Hollywood. And I was there before he was. He was the second one there. He came in and talked to me for 20 minutes. That was a question I asked him. He looked at me with this like enigmatic look. And then he just said, how about making it D? Alan Holdsworth actually said that to Shirtless Guy in 1998, believe that or not. It happened. It's hard to make that up, but it did. Okay, now that I'm almost done, sorry about all this rant. There's one more part of music that uses numbers, and that's rhythm. Again, now we're back to rhythm uses 1, not 0. So rhythm is more like tonal harmony rather than atonal harmony. In rhythm, you have 2 numbers in the time signature, okay? The bottom number is just whatever note value any note in the top has. The top is how many note values per measure, or bar, whatever you want to call it. That's the most important note. So if you have 4/4 time, it means just 4 notes per bar or 4 notes per measure. And each of those notes is a quarter note because it's 4/4. If it's 4/2, each of the notes is a half note. If it's 4/1, each note, you get that. But the counting you do, a lot of the counting is in the top number. If it's 4/4, the top number being 4, as well as the bottom, you count 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. that again, that's very similar to the tonal thinking, where you do 1, 2, 3, 4, 5, 6, 7. It's not rhythm 1, 2, 3, 4, 5, 6, 7, 8, 1, 2. But this time, instead of counting notes on a scale, you're counting beats in a measure. But it's still very similar to math, because if you're in 4/4 time, you're in base 4, aren't you? Only math would do it 0, 1, 2, 3, 0, 1, 2, 3, because there's always a 0 in math. Math would do 0, 1, 2, 3, 0, 1, 2, 3. But music and rhythm, we don't start with 0. We start with 1. So it's 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. It's base 4 counting. If you have 3/4 time or 3/8 time, that would be base 3. Math wouldn't do it as 0, 1, 2. Music does it as 1, 2, 3. Anyway, love you guys. Peace, love, and rock and roll.